So our next presenter comes from Netherlands, Azarakhsh. Yes, where is she? Yeah, okay. She's working at the Free University and in Gouda and presenting a paper which was prepared together with your colleagues. Yes.
Yeah, thank you.
The floor is yours.
Thanks. 10 minutes. Okay. Hello, my name is Azarakhsh Rafiee. So I want to explain a concept that me and my other colleagues are working on.
Meanwhile, I'll try to open a window because this place is meant for 50, but
Okay.
I don't know how many we have.
Okay. Okay.
Just keep on talking.
So, okay. Yeah, as we all know, urban population is growing very fast, and thus we see there and we face increasing in energy consumption in cities. In the Netherlands, 35% of the total national energy is being used in built-up environment, which leads to 30% of the total CO2 emissions. And from this 35%, almost half of it is being used in residential areas. So if we can, in a way, reduce the amount of energy which is being used in residential areas, the total amount of national energy can also reduce to a great extent. Oh. Yeah. So, as we all know that different elements have factors, has effect actually in the energy consumption of a building, from just architectural matter, building installations, behavior of inhabitants, income, age, lots of others. But one of the very important factors is the urban element, actually how the environmental areas are set actually. So this is related not to only your building but to your surrounding. So if we know the impact of different urban elements in a neighborhood, then we can design the neighborhood in a way that the total energy consumption will be reduced. So what do we need? We need first a model. So this model should give the impact of different roles like in presence of water, the geometrical construction of surrounding buildings, number of trees, presence of water, etc., etc. So if we have already a model which the role of each parameter is being known there, then we need to implement the model. Then we need a tool. And this tool, we should not have a tool which gives only an end result. So when lots of energy and time has been spent in designing, and at the end you say, okay, the result is not good, design from scratch, so it's not an efficient way of designing. We need a tool which you can design with it step by step. In each step of the design, you can get a feedback. So we actually need an interactivity between the tool and between the designer. We have used City Engine as an interactive design tool. We believe that it's a very good geodesign tool, and in each step of the design you can get just very fast feedbacks. So what we did, we just used a very, very simplified model. We've just assumed that, imagined that for each home, the building volumes and the trees and the energy level of the buildings has impact on the total energy consumption with the neighborhood. It's just a simplified model assumption actually. So to just calculate such impacts, we just needed the 3D data. We used the LiDAR data to get a 3D building model, and a 3D tree models was already provided from the same source by Altera, our partner. So we also get the volume of all the buildings and trees, and the last image you see the 3D trees and buildings standing together. And then we had also the energy consumption data in the postal code level in Amsterdam. Actually, in Netherlands, because of the climate situation, we assume that not so many cooling devices have been used. So that's why we use the gas data, which is related to heating. So the environmental has much more impact on gas consumption than on electricity consumption in the Netherlands. We have also used the energy labels, 150,000 energy labels, which are these data which are available as open data in Amsterdam. So when we have all this, so we have a rough model of the relationship between the gas consumption and the building's energy labels and the volumes and trees. And then to implement this concept, this model, we have used a City Engine for that. So in the beginning, in the City Engine, we have nothing more than lines and polygons, which later, by assigning different CGR rules, then you'll convert them to streets and buildings. So for each grouping each of these polygons together, we have the zones which are defined in the red by the red lines. These zones are actually our neighborhood for which we want to design in a way that energy consumption becomes less. We can apply different zoning rules. For example, the maximum height rule. So for this zone, you cannot build buildings more than this height. Or for example, the land use type. For example, for this part of the zone, you cannot build because it's a green area. Lots of other zoning rules you can apply it during the process or just before the design process. So actually, in City Engine, I don't know how much familiar you are with, but you don't have to design the, you can of course, but you don't have to design the objects by hand and one by one. So you can use procedural rules and then you can just writing these scripts as the rules. Then you can apply it in a very large scale, and then there's a very quite efficient way, especially in the designing process. So for example, as an example for this building, we can just define the height of the building, the size of the window, the number of stories, texture of the rooftops, lots of others. Then you can just do it only by programming. So very fast you can design a larger scale data. For example, in the right image we have the whole neighborhood design, which includes the buildings, the streets, and the trees. So in each object we can also have different attributes, and these are sort of our input of our model. So the height of the building, we can change it, and then you see that the height of the building changes accordingly. It's a pity that it's not a live demo. I have to show a picture. Or for example, energy label. So each time we choose one of these parameters, all the other dependent parameters will also change accordingly in the model. We have also received reports, which are somehow the feedbacks that we just receive in each state of the design. So for example, I have energy label and volume. For example, each time that I change the height of the building, the volume also changes accordingly. So if I select several buildings, I can see the sum and the average and the minimum maximum of the volume. These are only two examples. You can apply different report parameters, and then you see these reports parameters are changing when your design, each part of your design is changing. So assuming that we have now the volume of the buildings and trees and energy labels, we have just estimated the energy gas consumption within that neighborhood. We have colorized them to green, yellow, and red, which means low, medium, and high energy consumption. So here in the we can get the report on different parameters on the energy consumption or total tree cost. For example, each time you just put a tree on your environment, then you see that the number of costs will go high, because we assume that each tree has a sort of cost to plant it and to maintain it. Or now, for example, if we imagine that we want to settle a certain number of people in a neighborhood, say for example 600 people in a neighborhood, we can do it. We have different alternative ways to just settle these people. We can have settle these people in several smaller buildings or fewer bigger buildings. So the number of people is the same, but you see that in the left image you use the total energy consumption becomes more than in the right image, because of course, if you are living in a high apartments, then the people uses the height of the neighboring units, so you have to use less energy yourself. So in this, so only the construction of your environment is changing, and so you see that the total energy consumption, you see this change immediately in the very fast in the design process. Okay. Or for example, you have the same geometrical construction, but you have different number of trees, and we assume that the trees have certain effects on the energy consumption. So you see that with the changing of the element, environmental element, your energy consumption also changes. You see it immediately when you're designing. So actually, we believe that this city engine is a very good tool, a geodesign tool for this concept of our energy aware in interactive design. And we believe that different stakeholders or designers, they can all participate and in a step-by-step design, which in each step they get a feedback of their design. But to just participate, all the stakeholders together. One of the environment which we need is a collaborative environment, so that all of the from different parties, people, they can work together. So that's why we intend to connect a touch table to city engine. So this way the designers can, or the stakeholders, they can just benefit from the natural way of drawing or a collaborative environment, as well as the design functionality of city engine. As I said, this was about only the concept, but now we want to go further for the real model. And so to do that, we need a very detailed information of the energy consumption and of the environmental areas, very high detailed 3D information we need. So we want to use it in two different case studies, Amsterdam and London, because they're both major cities with different scales and different urban settings. So comparing these two results can give interesting conclusions for us. Yeah, thank you very much for that.
Thank you so much.